Assalamu alaikum. How are you, students? Hope fine. By the time you watch this video, you will be in the best of health, wealth, happiness. Right? Last time we have finished the chapter number 5. An exercise was remaining. So this time I intend to focus on the exercise also. So let us move to the exercise. Before the start of the exercise, you must all have your book open at page 114. So if you don't have the book, please go and pack your books. Hope you have the books with you. Now open it at page 114 and move on to the exercise. The exercise consists of 3 parts: the multiple choice question, the short question answers, and some comprehensive question also, and the numericals. And inshallah, I will try my best to focus on all part of the exercise. And uh, much of the part of this exercise has been covered in all the lecture, 99% rather. So if you watch the lectures again, then you will definitely see that you have learned all these things. You need only to apply your that knowledge. Okay, so Bismillah ar-Rahman ar-Rahim, let us start from the MCQs first. If you look to the first question, this see the encircle the correct answer from the given choices. The first question is: the Earth gravitational force of attraction vanishes at option A 64,000 kilometer, option B infinity, option C 42,300 kilometer, and option D 1,000 kilometers. So what is your right answer, class? What do you think about it? Let me help you in explaining this thing, and I want to show you one picture. So now look, you see that this is the distance between the two masses. Now you will see that how the force will look like when I play this video. You see, look, when the distance is small, this is the distance small, this is distance axis, and there is force axis. So when the distance is small, then what is the force? The force is very large. Now as the distance increases, you see the force decreases. But you see that it never crosses the x-axis. It is just like going like this way. As you see, let me just do it for you. You see, look, it just goes this way, kind of exponential curve. It never goes this way, right? So if it were to be going this way, then the force would become 0, right? But this is never happening. So as long as you have the masses, you have the distance, right, then there will be the gravitational force. So the gravitational force never vanishes between two objects, though it might be very, very small, even maybe smaller than this, right? But it will never vanish. So our correct option is infinity, right? What do you think about it? Let me help you in explaining this thing, and I want to show you one picture, and it will be more interesting for you. If you see, look at this, watch this. See here. Right, animation has. Okay. Now let us see what is going to happen. You just see, look at this thing here. If you have two masses, m1 and m2, if they're separated by distance d, you see as the distance increases, look, the force decreases, but it never passes through the 0 line. It will never cross the x-axis. What does this mean? That the force never vanishes, right? Why? As long as you have distance, no matter how small or large, and as long as you have masses, so you have the gravitation between them. So if you just see, look at this, this is how you can now choose your answer. So what is the right answer? You just choose. Hope you will choose which one? The option D, infinity, because it does not become 0. Okay, that point. Now let us see what is the next one. The value of G increases with option A, increases in mass of the body, increases in altitude, decrease in altitude, none of the above. For this, you need to write the formula. And if you remember, this most probably it was the third lecture, the variation of G with change in altitude. So you just see, let me write it for you. Look, see here, look, what is the appropriate formula for this? The value of G at that altitude, G is inversely proportional to R square. One, you have done this thing. And the second important point which you have done was the value of G at particular altitude. It was Gm into what? R plus H whole square. So you see, as the altitude increases, G decreases. So if the altitude decreases, G would increase. So definitely the right option is option C. This is our right option. Clear? Now let us move on to the next level. See what is there in the next. Number third, the value of G at height 1 Earth radius above the surface of the Earth is option A, 2G. This G means here the value of G on Earth. Okay, G is equal to the value of G on Earth. Most probably in your book it is 10 meter per second square. So you see, look, what is going to happen here at this point. Look, the same formula, you don't need to go too far. Okay, and what you will be doing, you just see, look, one radius of the earth, so G at that height, you just see put Gm into R plus R whole square height, because in this they are telling to you that one earth radius, altitude is equal to one earth radius. So R plus R, of course, it will be 2R, and you will see that it will become Gm, and it will become what? 2R, and at the end it will become what? So it will become equal to Gm into 4R square. So you see, G at that altitude will be then what? G at that altitude. From this it will become equal to what? What is this Gm by R? Of course it is that the value of G on the earth, right? So the surface of the earth, so G on earth 4 times. So of course we have this is our answer. Right, now let us move on to the next point. In the next point, you see the next question. The value of G on the moon surface is 1.6 meter per second squares. Per second square. What will be the weight of 100 kilogram body on the surface of the earth? So this is as easy as eating ice cream. You have done many times this thing. So what it will be? W is equal to what? It is equal to mg. So you have mass, you have the value of G in the surface of the moon, you multiply, and the answer you will get is 160 Newton. So we have this answer. So the correct option is 160 Newton. All right. Now let us move to another MCQ. This is that the altitude of the geostationary orbit in which the communication satellites are launched above the surface of the earth is. So this is what I already told to you, and if you just open your book and where you see the satellite, and most probably I still remember if my memory is sharp, so it was on the left side of the page, left top margin. In there it was written that this altitude is this one. Of course, you can even calculate. We have the formula with us. The next one is the orbital speed of low orbit satellite. That what is the orbital speed of the low orbit satellite? So look, that is what the right answer is 8,000 meter per second. Why? Because that if you just remember, I did it to you that that the V orbital, the V orbital. So you remember that we were using the V orbital, and that was equal to G R under the root. We came out to be 8,000 meter per second, and then we put it like 8 kilometer per second, and then in term of the kilometer per hours also. So it is already done. So this is not a very surprising question. This is very easy, right? Now let us move on to the question session. Now, what is the in the question session? The first one is what is meant by force of gravitation. So if you remember, I told you that the force of gravitation is in fact what it is, the force of pull between all kind of masses, right? Gravitation is the intrinsic property of masses, the natural property of masses, and it is the force of attraction. So that is very easy, we already explain it, so I think we should not give any more time to it. Number third, do you attract the earth or the earth attracts you? Which one is attracting with a larger force, you or the earth? So this is very simple if we apply the law of gravitation to it. If you remember my very second lecture, I think, where I was explaining to you the force of gravitation, you remember that? And then I told you that, look, I just use my ruler. Let me use it here. Yes, I'm able to use it. So you see that there was a center to center distance between the two. Okay, so let the ruler be. Okay. Okay. So you see that, look, F, for example, if I just consider this as U, right? And F, no, not this U, because center to center distance will be my U, right? So if this is U, I label it your mass as M1, I label your this mass as M2, and I label this distance as D. So you see that if you apply the law of gravitation, so what is the law of gravitation? You remember F was equal what? G M1 M2 by D square. So you see this does not depends on the mass of one body, it depends on the product of the two, right? So one is this thing, and second, I told you that if you see, look, there you have two kind of forces, for example, one this and the other force is this. So this, if you remember, I told you that this will be the force 2 on 1, and if you remember, this will be the force 1 and 2. And now you see, look, I told you at that point that these two forces, see, F12 is the same as F21, because we cannot deny the Newton's third law of motion. So the forces are the same, but they are acting on two different bodies, objects. This is the force which 2 on 1. So the force that the body 2, earth, exerts on you. And this is the force 1 on 2. That is the body 1, means you exerts on the earth. So definitely these two forces are the same in magnitude. So you and earth both exerts the same force on each other, right? You are attracting each other with the equal force. But you are accelerating towards the earth while the earth does not. And what is that simple reason? That simple reason is acceleration inverse proportional to mass. Your mass is less, so you are accelerated towards the earth. Earth mass is greater, the same force cannot produce that much enough acceleration, so the earth does not seem to be moving. So which one is attracting with the larger force? Same force. You are the earth, same force, right? So that is this one. The next question is that what is a field force? Field force, if you remember, I told you that field force is the force which exists all around the body, and it is the force which acts at a distance. It is a force which requires no physical contact. It acts at a distance, so that is usually a field force. And this is what I explain in my lecture, if you remember. So I think no more comments on this. The next one is the why earlier scientists could not guess about the gravitational force. So you see, look, that is also very easy. If you just see, look at this. Let me explain it to you with a different pen with this, right? You see, look at this equation. What was this gravitational force? See, the gravitational force F in fact equal 6.673 into 10 raised to the power minus 11 Newton meter square per kilogram square into m1 m2 by d square. So you see, look, this is the most problematic factor. You see, this is extremely small. So you know that this force exists right from the big bang, right from the beginning. But the force is so small between ordinary objects that people usually cannot just encounter this. They cannot just develop any kind of idea about this thing. For example, if you have 1 kilogram masses and if they are 1 meter apart, so what will be this force? For 1 kg mass, let me use a different pen so you can understand it easily. Let's see this one. If, for example, you have this 1 kg, and if you have this also 1 kg, and if you have this distance 1 meter, so what would be this force? 6.673 into 10 raised to the power minus 11 Newton. So how is this force? Very small force, right? This is extremely small, unnoticeable. So we cannot notice this thing. So this is one of the reasons that the earlier scientists could not refer to this thing. So that is one of the reasons that I think that they did not give any proper head to this. Let us move on to the next question. And the next question is, the next question is, how can you say gravitational force is a field force? This is a repeated question. Gravitational force is a field force because it does not require any physical contact between objects, right? It acts at a distance. So this done, most probably we don't need it to explain it further. Explain what is meant by gravitational field strength. So the gravitational field strength, if you remember, the gravitational field strength, you see, in my that lecture, I told you that the gravitational force acting per unit mass, or rather it was the weight of an object per unit mass. So that is gravitational field strength. And then I told you it is measured in Newton per meter square. Larger this value, greater will be the gravitational force. Smaller, sorry, smaller this force, smaller will be the value of the gravitational force. So is this thing. The next important question is which one? That is that why the law of gravitation is sorry, explain what is mean the gravitational field strength. This is what I explained to you, I think. Yes, it is this one taken. Okay, the next one is why the law of gravitation is important to us. The law of gravitation is important to us. That it is because we use the law of gravitation to calculate the masses of the planets, stars, which we cannot do directly. So that is one of the most important point. Number second, we use the law of gravitation to find the exact orbital velocity, to place the to find the exact orbital velocity for the exact orbital velocity for the satellites, right? So that is why it is important. Explain the law of gravitation. We already explained the law of gravitation, so I think we don't need it any further. Look at this diagram. You see, this is the artificial satellite and it moves around the Earth with the same speed as the speed of the Earth about its own axis. So the rotational, that is the orbital speed of the satellite, is equal to the rotational speed of the Earth. Now the question is why. It is because that it always points towards the same point on the Earth. The reason is that because to make the communication between the satellite and the Earth station easy. So if look, if there is the Earth station, right, then you see, look, as the satellite moves, as the Earth moves, right, you know, the Earth station also moves, and because the speed of the satellite is the same, so it always point to the world the same point. You see this dot. So the communication between the Earth station and the satellite is always synchronized, right? So this is one of the reason that the geostationary satellite have the same orbiting speed. Is which one? The next one is the how the Newton law of gravitation helps in understanding the motion of the satellite. As I already told to you that we can apply the law of gravitation to find the exact orbital speed for the satellite. So this is how it is important. The next question is that on what factors the orbital speed of the satellite depends. So you see, if you remember one of the last equation of the chapter which I was explaining to you, that look, the V orbital. For the V orbital, we have what? We have V naught, if you remember, and it was equal to G at that height into R plus H. So you see, now you can easily tell that it depends on what the altitude. This volt is R plus H is the radius of the orbit of satellite. Radius of the orbit. So it depends on what the radius of the orbit. If the radius of the orbit is large, you will need a greater orbital velocity. If this radius of the orbit is small, this will be small, right? So this is how it depends on this thing. And if you remember that lecture, I told you it does not depend on the mass. Remember why? Because there is no mass involved in this expression. So of course, this is what you can explain in your that answer, right? So you are not supposed to write it in this way in your paper. This is what I just explained to you. So inshallah, in the next lecture, I will be solving the numerical to you. I'll be telling to you the technique, how to solve a particular numerical, what steps we would follow to solve, right? This is, inshallah, this will be our next lecture. Now, we have even much time for left for the Zoom question answer session also. So I'll be waiting for you there, and inshallah, I will answer all of your questions. Thank you very much. And Allah Hafiz.